Welcome to part 3 of Notes Lesson 8-1. Let's begin. All right, number 12 on the Check Your Understanding. It says describe the transformation of f of x equals square root x. Now you should have already done these, so you're just checking your answers. So to describe the transformation and state the domain and range. So describing that transformation, our transformation will be that we are scaling, right? It's a vertical stretch by a factor of 2 because a equals 2. And it says that k or h equals 3 and k equals 0, so there's also and also translate to the right 3 units. All right, so now using that structure that we saw in the previous notes, the domain will begin at our h value, which is positive 3. So the domain will be from 3 to infinity, and the range will begin at our y value, which is 0 to infinity. Now, sometimes you have to be careful with the range. I'm going to make a note here. If there is a reflection, your range will switch signs. So imagine that if we shifted this graph upward, which we didn't, but if we shifted it up 4, but we had reflected it, it really would be down 4. All right, let's look at number 13. It says to graph this function using your knowledge of transformations. So on number 13, I'm going to draw my graph. Now, it's really difficult to graph transformations with no graph paper. So I'm going to do my absolute best. So g of x equals x plus 2 to the 1/2 minus 1. Remember that g of x equals x plus 2 to the 1/2 is just square root x plus 2 and then minus 1. So that tells me that this graph is shifting h equals negative 2, so left 2, k equals negative 1, so down 1, and there is no scalar reflect because a equals 1. So I'm going to take my parent, I'll do my parent in green, 0, 0, 1, 1, 4, 1, 2, 3, 4, 2, and 9, comma 3, and I'm going to shift this graph left 2 and down 1. So this will shift left 2, down 1. This point shifts left 2, down 1. This point shifts left 2, 1, 2, down 1. And this point shifts left 2, 1, 2, down 1. And there is g of x. All right, next, give a transformation of the square root function that has a range that approaches negative infinity as x approaches positive. Oh my goodness, I just realized that I made an error in the previous notes. So I'm going to go back to this right here. This function, g of x, my range is going downward forever, not upward forever. So I'm going to go back and fix that right now. Please do the same. So flip back to page 105 if you're not already on it. And can you please fix your range? Your range is going to negative infinity, so please correct that. Did anyone else catch that? If you did, bravo. If you did not, please correct it now. So now let's go back to this question. Give a transformation of the square root function that has a range that approaches negative infinity as x approaches infinity. So as you're going to the right, this graph is going downward. This would be an example of that. So let's talk about any function that could do that. So number 14, here's an example. I could make a function f of x equals, what would have to happen for this graph to be going to negative infinity, right, would be that the graph had to reflect. So I do need a reflection across the x-axis, and then I can have any values I want for h and k. All right, so I did make a note of that. In the beginning, I said if you're reflecting, your range will switch signs, meaning that your beginning point and end point, it'll be going from negative k to negative infinity. Okay, all right, so here's an example. And use the graph of h of x in item 10 to make a conjecture about the solution of this equation. So this is to use the graph of h of x in number 10. So here's h of x to make a conjecture about the solution of this. So I would say that the solutions are where the graph crosses the x-axis. So my conjecture, since this graph does not cross the x-axis, is that there are no real solutions. The graph does not cross the x-axis, so there are no real solutions. All right, let's go ahead and flip this guy over. It says the graph of the whole speed of the boat, h, is shown below. You also sketched this graph in item 1A. Use the graph to estimate the whole speed of a boat that is 24 feet long at the water line. So here's the length of the water line, and we're looking for where that is 24 feet. So we're going to this point. And we are estimating, but when I go up to the graph at that point and then go over to the y-axis, it's about right there. It looks like maybe 6.75. So the whole speed would be approximately 6.75 knots. Then it says, use the graph to estimate the length at the waterline of a boat whose whole speed is 6 knots. So this time we're given the whole speed is 6 knots. So I'm going to go to 6 knots, and I'm going to go over to the graph, and that point would be at 20. So the length would be 20 feet. Excuse me. And then finally, write an equation that could be solved to determine the length at the waterline of a boat with a whole speed of 6 knots. So with a whole speed of 6 knots. So I'm going to go back to my function. My function from this problem was 1.34 square root x. So we had h of x equals 1.34 square root x. And remember, x represents the length. And this one, they want to know if we could determine the length with a whole speed of 6 knots. So I'm going to plug in the 6 knots. Here's my whole speed. So this means 6 knots is equal to 1.34 square root x. And that's an equation that can be used to solve that. Okay. I want you to pause your video here and do the check for understanding. I will do it as well, so you can come back to get some clarification. All right, number 19. The graph at the top of the page says use the graph at the top of the page to estimate the whole speed of a boat that is 9 feet long at the waterline. So you should have gone to 9 feet, looked up at your graph, and seen that the whole speed is about 4 knots. So about 4 knots. Explain how you can tell from the graph above that the equation relating the whole speed and the length is not h of x equals square root x. I can tell that it's not. I can look at any one of my key points that should be on the parent, right? The parent should be right there, and it's not. Or I can look at 4, 2. It's not there. I can choose points known on the parent. And see if they lie on the graph, which they don't. All right, this has been Notes 1-3. I know it was lengthy. I appreciate your time. Have a good day, and I will see you in class tomorrow.